Hey guys, I'm just going to go through the few problems on the yellow assignment that covers direct variation, and this is just so you have an idea of what you're expected to do on this assignment. Now, I'm not talking about anything that's on the back, so that you're going to have to, get taken care of yourself. I'm giving you until Wednesday to get this assignment taken care of, so please get it back to me by Wednesday. That's plenty of time, all right? Okay, here we're dealing with direct variation. Now, as we've said in class, the thing that always should happen is we should always have a y-intercept of 0, 0. So these first three questions, all you're really looking for is whether or not the equation has a 0 for its y-intercept. So for instance, y equals mx. The y-intercept is 0, so we're not including it in the equation, which means that here, this works out. There's their y, there's our slope, and there's our x. So this is, yes, a direct variation. Now the constant of variation, that's going to be, well, it's the only number in the equation. All right. The one thing I'm going to point out here is that this equation is already solved for y, which means that if you have an equation that's not already solved for y, then you're going to have to solve it for y. So that's something you're going to need to be able to do. There's number 1. Here's 2. 2 is dealing with graphing. Because this is a linear equation, that means it gives you a line, and we have a slope, we're going to be able to graph this. Again, the point that we always want to point out is that the y-intercept is 0, 0. So you know that you already have the point 0, 0. Starting point. And now I'm going to be able to use the slope. So my direct variation here is y equals 1/2 x. The slope would be 1/2. Now what that means, and this is from the first semester, so it is stretching back a little bit for you, all right? Y values are on top and x values are on bottom. This is the slope, which means that my y values are going to change by 1 and they're going to go up. So that's going to be plus 1. My x values are going to move to the right because it's positive, and it's going to go by 2, so plus 2. So what that looks like here is, from my starting point, I'm going to be adding 1 and adding 2. There's my second point. Now I'll be able to draw a graph that passes through those points. There's number 4. All right, and here's 7. You gotta make sure that you read through and understand exactly what you're being asked to do here. The graph of a direct variation is shown. Write the direct variation equation, so that would be here, and then find the value of y. So y equals what if x equals 10? Well, just like before, we have an x value and a y value. So that I can write down the direct variation, first I'm going to have to come up with the constant of variation. To do that, I'll use my y value and my x value. Now once I have my constant, then I'll be able to write down my equation, and I'll be able to figure out what the y value is if x is 10. So here, to solve for the constant, I'm going to have to eliminate 2. I'm going to do that by division. Okay, so now I've divided, and I know my constant of variation is going to be 3 over 2. Taking this information, I can write down my equation, 2x, and I can also find out if my x value is 10, so y equals my constant, and if x is 10, then what does y equal? Well, 3 over 2 times 10, 3 times 10, there's 30, and divide that by 2, so that's 15. All right, so that means my y value would be 15 if my x value is 10. So here I'm going to have 15. So that's 7. All the problems, 8 and 9, they're very similar to that. Lastly, there's the table. This would probably be the more challenging part. Now, a lot of people just look at this and think, oh, well, I'm just going to put this into the calculator. I have my table. I'll just, throw it in. Well, if you don't have a calculator, like at home, then that's not going to be an option. And seeing as the only day I'm giving you to work on this was today, you're going to need to find another way to do this. And what I did in class was I looked at and I thought, okay, if I know that this is direct variation, which means that I could write the equation like this, then I should be able to figure out what my constant is, what my slope is. Alright, well, all I would need to figure out what my constant is, if I could just put a number in for x and a number in for y, so for instance 9 and 0.5, then I'd be able to solve for my constant, my slope. So doing that, again, this is m times 0.5, so I'm dividing there to undo that. Alright, so then what I find out from this is that the value of m, my slope, is 18. 9 divided by 0.5, that'll give you 18. Okay, so this is my constant, or at least it should be. Now the idea behind direct variation is that if I have this, and this is the equation that I'm working with, then if I use 3 for my x value, then I should get whatever the y value is here. 3 times 18, that's 54. That's correct. Now, if this is the constant for this whole table, it should work for each number. So, for instance, here, I just do negative 2 times 18. That should give me negative 36. It does, so that's right. 1 times 18, that gives you 18. Negative 8 times 18, if you want to use a calculator to check me, you can. But that does give you 144. All the numbers work with this one constant. That means that this is going to be the equation that shows this table, and this is a direct variation. So yes, it is a direct variation, and here's the direct variation equation that goes along with it. Alright, so that's those few questions there on the front. Back's all yours. Again, it's due on Wednesday. We are also having another quiz on Wednesday, so look out for that. Alright, see you guys.